Hello, everybody. My name's Ian. I'm from the Stakehodler. We're an organization whose mission is to build tools for the Web 3.0. And today I'm going to talk you through the proof of concept for the proxy voting service. This is an idea whose roots are in traditional finance. In the past, I used to work for an institutional investor, and we would use a proxy voting service provider. The reason being that we held lots and lots of stock, and we were expected to vote on every ballot for every company which we had shares in. And this task was impossible because, as a corporate governance team of less than 10 people, it's just impossible to vote on thousands and thousands of ballots. Therefore, what we would do is we would submit a one-time policy, which was essentially an Excel spreadsheet, which just had a list of different conditions, such as if the chairman is above 75 years old, then vote against. If there were less than 40% of women on the board, then we would vote against the chairman, and a whole other range of objective conditions which would vastly minimize the time that we would have to spend on voting. This would free up time for us to do other things, such as focusing on controversial votes or engaging with board of any company to which we had some pressing issue. Anyway, this proof of concept is essentially the first implementation of that on-chain. So what I see at the moment is a lot of delegation going on to other people. And this is great, but it doesn't give users the opportunity to delegate voting in a way in which they are guaranteed that the votes are executed according to their policy and therefore their values and beliefs. So this is what I'm introducing today. So it's based around the compound governance system. What it will do is it can cast votes on given proposals, and it will do so based on a series of if-else conditions. In this case, I've written in those if-else conditions into the smart contract, but in the future, I would imagine that this proxy voting service would need to rely on things such as oracles or optimistic execution. So what I'm going to talk you through today is the deployment, where in phase one we'll just deploy our compound governance system. In phase two, I will deploy the proxy. This is the proxy voting service contract. In phase three, I'm going to prep the wallets and the contracts to execute voting and to submit proposals. And in phase four, I'm going to submit a proposal via one address, and we're going to watch how the proxy voting service behaves in the wild. In this instance, the proxy voting service executes on a very trivial condition. It's not something that I would expect in production, but it presents the concept and is just a simple way of doing so. The condition is to vote against, or no, sorry, the condition is to do the opposite to what a nemesis address is doing. So let's go through the phase one. All I've done so far is I've git cloned the repository and I've copied the env.example file into the env file, and I've entered my API and other private keys, which is up above, and I'm not going to expose it now. But that's it. So this is live as you see. And first command I'm going to run is yarn. Okay, the very first step is to deploy our compound governance system. Everything is in the README, so you can follow through yourself or just do it in your own time too. This example is going to use 3 addresses. Each one is linked to my MetaMask. So this is my MetaMask account 1, this is account 2, and account 3. What we're going to do in the to deploy the governance compound system is we're just going to assign all of these to account 1. I've done some customizations to the compound governance system. I reduced the time lock to, I think, something like half an hour, and I'm going to send the full token supply, which is 10 million tokens, to account 1. The other 2 arguments here are to define the admin, and in this case it's also address 1. Of course, this wouldn't be the case in production, but for the demo, I think it's okay. Okay, cool. So our governance system has deployed successfully. To the keen eye, you might notice that I've had to run the command twice. I just paused the video to save you all the time. Okay, so I'm going to make a note of this. These are the deployment addresses, and I'm also going to plug them into the env file. And for good measure, we'll also see the token supply on my MetaMask wallet. So I'll add the token in now. Okay, there's my 10 million. Okay. So the next step is to deploy the proxy voting contract. Normally, if you were doing this yourself, you would have to go into the contracts, you would have to go into your proxy voting service contract, and you would have to enter an address for your nemesis address. For all extents and purposes, I would make sure that it's your address 2 of the 3 addresses you're using, because that will fit in with the rest of the flow of this example. I've used my address 2. So COX323. If we go over to MetaMask, you can see that it is also OX323. Okay, so if you had done that and you change it, you would need to recompile the contracts. But we don't need to do that in this case. All we need to do is deploy our proxy. The one thing our proxy needs to know about, which is in its constructor, is what the governor address is, the one it should monitor. Well, not monitor, but the one that it's primed to execute on. So we'll deploy this now. Okay, awesome. So our proxy voting service has been successfully deployed. I'm also going to make a note of this here and plug it into the env file. So now that all our contracts have been successfully deployed, what we're going to do next is we're going to transfer the tokens that were in account 1 to account 2 and account 3. In this example, what I'm going to do is I'm going to send account 2 3 million tokens, and I'm going to send account 3 7 million tokens. So account 1 is going to have 0 tokens. And I'm doing this because I want account 1 to execute the proxy voting service contract. And I just want to ensure that there are no tokens from the account that's actually executing the proxy. I want all the voting power to be from the proxy itself. So now we're going to transfer the funds. Okay, cool. So the transfer functions have gone through. We just need to wait for it to be confirmed onto the network. We can verify this by just checking the token supply of address 2. Three million tokens here. Okay, now our next step is to delegate the voting power of address 2 and address 3. In the case of address 2, we're just going to delegate it to ourselves. So delegate to address 2. And for address 3, we're going to delegate it to the proxy. Okay, so the functions have executed successfully. Now I'm going to also look at the events of the contracts on Etherscan. The three I'm going to monitor are the token, the governor alpha, and the proxy voting service. So we'll just do this quickly, set it up. Okay, there's our two delegate functions. Nothing so far in the governor alpha, and we don't expect to see anything in the proxy either. Great. So now we'll go on to phase 4, where we're going to submit a proposal, and we're going to also submit some votes and see how the proxy behaves. So I'm going to submit a proposal first. This proposal is going to come from address 2. I'm not using address 1 because there is no tokens on address 1, so it wouldn't pass the threshold for being able to submit a proposal. And that's it, basically. Okay, so the proposal is going to be very trivial. It's a basic transfer function here, just to send a small amount of funds to address 3. Okay, cool. Our proposal has been submitted, so we can verify this on Etherscan. There it is. And now we're going to run the proxy voting service, telling it to vote on proposal number 1. Note that there's no need to tell the contract how to vote, since that's its purpose, is to determine objectively how it's going to vote. So I'll do this now. All right, so that's been executed. Now let's quickly review the proxy voting service contract. I'm not sure if I explained earlier that it just does the opposite to a nemesis address. If the nemesis has voted for, then it will vote against. If the nemesis has voted against, then it will vote for. And if the nemesis address is yet to vote on that specific proposal, it won't do anything. It just emits an event that tells us that no vote has been cast. So in this instance, we are expecting no vote event to be propagated, and that's it. Okay, here we have it. No vote. Next, we're going to cast a vote with address number 2. Note that this is the so-called nemesis of the proxy. Oh. Okay, cool. So now we've cast a vote with address 2. We should be able to verify this by looking at the governor alpha events and transactions. Here it is, cast vote. We have, this is address 2. Vote in favor, and it cast 3 million votes. So now let's see how the proxy behaves. Since the address 2 has voted for, we're going to expect the proxy to now use its 7 million delegated votes to vote against. Okay, now that transaction has been successful, I hope it's propagated around the network enough that we can see it on Etherscan. Looks like it hasn't arrived yet. I'll try one more time. Oh. Okay, there it is. These are the events from the proxy telling us that it's voted against proposal 1. We can also confirm that this has been executed on the governor alpha here. 7 million against. I know I've been saying 7 million here when in fact it's not. Okay, so that is the extent of the demo. I know the example used in the proxy voting service contract is trivial, but I think the scope and the potential as an alternative to delegating to other people is considerable, especially given the fact that it is the de facto approach in traditional finance. And there are companies such as ISS Governance and Glass Lewis who are million, if not billion-dollar businesses that do this for institutional investors. I think voting abstraction is a difficult issue, and we're going to need more and more tools and solutions around it based on different users' needs. So, without further ado, I'd like to say thank you very much for listening, and I'm looking forward to hearing your thoughts and feedback on this proof of concept. So, thank you very much, and bye. Goodbye.